So number one and number two, if you don't remember how to do that, I'll do that quick. But just a heads up, the days of me factoring where I do the X factoring, I take the first number times the last number, the middle number, and then I do factors of -6 to add up to be +1. I'm probably not going to do that. If I get to one that I have to, honestly, I can't do it in my head. I can do that, but you guys need to be able to, I guess either, if you need to do that, go ahead and do it. If you have questions on that, I will 100%. If you want me to, I will write that out for problems. Just ask. But it's one of those things, like I said, you guys got this in Algebra 1. We did a whole chapter on it here last semester. So you guys should be at a place where you can do those. However method you do it, you should be pretty proficient with those, especially not a leading coefficient. And like I said, in my opinion, that's the, I don't know if I'd say the hardest. I'd say today that's probably the hardest part, is factoring stuff. So remember what we did, oh shoot now, I mean, I think it would have been in quarter 3, where we had two functions, and then I said we did adding and subtracting, and we multiplied, and then I said now you have to divide those two functions. So the first thing we did was take x squared plus x minus 6, because that's the function f, and then x squared minus 9, because that's the function g. Today, the biggest difference is it's already, a lot of them are already set up for you, or at least the beginning part, or the beginning ones we do. And then to solve this, hopefully you guys remember, you factored the numerator, which ended up as factors of -6 to add it up to be +1. So x plus 3, x minus 2. Getting that, please ask. But I mean, I don't want to be rude when I say this, but you're a little bit behind if you're not understanding where that's coming from. Like I said, we've done that a bunch. Also, though, if you don't understand where I get that answer, or let's just say you know that I make mistakes doing stuff in my head, so if you got a different answer, don't be scared to ask how I got it or correct me, because, again, I'm not super good at doing a lot of these in my head. Put some of these on purpose on your review, because, again, hopefully, even if you do this, hopefully after the because I put questions on here with factoring. X squared minus 9 is x minus 3, x plus 3. In the numerator and the denominator, we could cancel those. So that means our answer was x minus 2 over x minus 3. Now, a couple things. We cannot cancel the x squareds at the beginning because you have to be multiplying before you cancel things. So that's x squared plus x. That's adding. That's not multiplying. The denominator is x squared minus 9. That's subtraction. That's not multiplying. You can only cancel like this if it's multiplying. If you look at the we did after we factored, it was x plus 3 multiplied by x minus 2. That's why we'd cancel. And in the denominator is x minus 3 multiplied by x plus 3. So it's got to be multiplication to cancel. Excluded values, you remember your denominator cannot be 0, so go into your denominator after you factored. After you factored, before you canceled. Cannot make those zeros. So the first one would be +3, the last one would be -3. Try not to forget those. And honestly, on the test over that one, I didn't count you wrong. I think it actually made an extra credit. On this, I'll probably put 1 or 2 of those on. I'll remind you. I'll put somewhere. The hardest part to bring, but I will probably count it for this test. We did that back whenever. If you don't remember, if you did not remember that, that's fine. It's something that, I mean, it's a complicated one. It's been a while since we've done it. I get it. But after seeing it, you need to make sure, hopefully you kind of vaguely remember. If you do, that's good enough. Again, we're going to go over a whole bunch of these. It's h j, so h is x plus 8 over 4x plus 32. The only reason I added the second one is to show you that some of them, there's a little less factoring. So the numerator can't factor. The denominator, all I can take out is the greatest common factor of 4, which leaves x plus 8. Now the same thing, x plus 8's cancel. So in the numerator, everything canceled, so you need a 1 there. If everything cancels, you need a 1. Technically in the denominator, if everything cancels, you don't need a 1. But honestly, if you're worried about it, or if you're going to forget, just anytime everything cancels, put a 1. If you have a 1 in the denominator, that's fine. I can live with that. And the denominator, all we have left, everything canceled but a 4. So 1/4 is our answer for that one. And for this one, the excluded value, x cannot be equal to -8. You don't have to worry about that 4. That 4 isn't multiplied by anything. It's only what makes that denominator 0. The only thing that will make that 0 is -8. If you try -4, it doesn't work. It doesn't give you 0. So again, today, when you picked up the notes and looked at those, if you didn't remember how to do those, that's fine. Or vaguely remember, as long as you have a understanding, honestly, as long as you can factor. I tried to do this segue to help you guys, but even I could have skipped this, and I think a lot of you guys would be okay. So the next ones that we're going to do, this is what they're going to look like today. We're going to start with multiplying, then we're going to be dividing. For all that, skip around a little bit. But you do the same thing as what we just did. So really, the only thing with these next ones is they're already set up for you. They're not set up as a division problem. They're set up as a rational means a ratio, means a fraction, and these are expressions. So that's why this whole chapter is rational expressions. Again, it's literally just a fraction with expressions. So same thing as before, we factor these. I try to do a favor for you guys. X plus 4 squared. If you want to write that, you can. I don't write it. I write it as x plus 4 times x plus 4. So it's the exact same thing we did before. They just already have it set up in this set. So go ahead and factor the denominator. Factors of 8 add up to 6 are 2 and 4. Just like the ones we just did, if you have something in the numerator and the denominator, they can cancel. Now, here's the big thing with this. Hopefully this is obvious. To me, it's obvious, but I've done algebra now for like 14 years of my life. I can cancel x plus 4 and x plus 4. I can cancel the second x plus 4 because there's not a second x plus 4 in the denominator. Once it's canceled, it's canceled. So it doesn't matter if you use the first one or the numerator. But once this one cancels the one in the denominator, there's not one in the denominator left, so that first one, you can't cancel that. Again, I hope that's kind of an obvious thing, but if I don't point it out, some people end up missing. So for this one, ends up being x plus 4 over x plus 2. But again, try to remember your excluded values. X equal -2, 4. Again, it's the sweet spot after you factor, before you cancel. Now, per usual, don't lose any sleep over that. If you're struggling to get a 60%, maybe that's something that you're not going to have to beat your head against. There's only going to be like 1 or 2 questions that include that on the test or on the quiz. But there are going to be some questions on the test or the quiz. So if you are a B student, maybe that's something you're going to worry about. That said, what I said earlier, I think, in my opinion, the hardest part of the excluded values is just remembering. So I'm hoping on the test I will put like excluded values and have a blank spot. So I'm hoping that reminder makes it so it's not too bad. These sometimes they're called restrictions on the variables. I thought about changing that, but I thought it was not a bad idea to expose you to new definition. So the excluded values are also restrictions on the variable. They both mean the same thing. So number 4, I can factor out an x. Again, the numerator, a lot of people get confused because they don't know what to factor. Factors of 0 that add up to be 3. No, it's just take out a greatest common factor. I can take out an x. That leaves x plus 3. The denominator is x plus 3 times x minus 3, difference of squares. And again, from here, if you have the same thing in the numerator and the denominator, they can cancel. So all we have left is x over x minus 3. And your excluded values, x cannot equal -3 and +3. Any questions on those? Okay. Moving on to the next one that I actually will argue it's basically the same. Now we're going to go on to multiplying. So multiplying, the first thing I like to do is remind you how we multiplied just normally, because I know a lot of people don't enjoy math and they don't get it and they don't understand. I get that. But the thing that I do like about math is it doesn't change. So back in elementary school, when you learn how to multiply these fractions, that's what you're going to be doing today. The only difference is now we don't just have numbers, we have expressions. But remember, back in the day, the way you multiply fractions is you just multiply straight across. The numerator, 4 times 5 is 20. The denominator, 3 times 7 is 21. Produce, please do so, but that's all you do for that one. Now the next one, number 6. Yes, you do the same thing. 6 times 9 in the numerator, 2 times 5 in the denominator. However, I'm going to show you a different way with this one, or a way you've probably seen before, where you reduce. So for instance, the 6 over 2, you can reduce that fraction to 3 over 1, and then multiply. 3 times 9 is 27, 1 times 5 is 5. The reason I'm showing you that is because that's the way you're going to do these other problems. Technically, these other problems you could multiply straight and reduce. That's being a nightmare. But the other way you can do a problem like this, like number 7, is you can cross reduce is when it's multiplying. I don't think we went over it this year, talk about it a lot. But if you have 3 over 4 is equal to x over 10. Actually, I should do this. Hold on. X over 9. You do not cross reduce this. A lot of people get cross multiplying mixed with cross reducing. Cross multiplying is this one. 3 times 9 is 27. 4 times x is 4x. That's cross multiplying. We only do that if it's equal to each other. You do not cancel those out to have a 3 here. That's when you reduce. That's with multiplying. The good news is, if that confuses you, you do not do any cross multiplying in this chapter, or at least in this lesson. I guess I shouldn't say that. I think this whole chapter. But cross reducing is what we're going to do today. So the 2 and the 4 can cancel. 2 goes into 2 once. 2 just like you can. So 1 times 3 is 3. 5 times 2 is 10. That's your. Now the last one I'm going to show you is because it's a little bit interesting, because there's more reducing that you can do. For instance, the 18 over 3, you could reduce that. That's 6 over 1. But also I can still now reduce that 6 and the 2 if you cross reduce. So 6 and 2, you can divide both of them by 2. So that's 1 and 3. So now everything we have left, we multiply. 3 times 5 is 10. And then 1 times 1 is 1. So that one's just 10, or 10 over 1. 15. Thank you. Now, again, I know that I'm hoping that sounds trivial, and I'm hoping, again, one of those things that you guys probably didn't just like. If I would have given you those problems, honestly, some of you guys would not have been able to figure it out. That's okay. As long as now you kind of understand where those are coming from, that'll help you. But the punchline, the reason I'm doing that is because you do the same thing. So the only difference now, we're going to factor everything. That's going to be the first step, factor everything. Then, just like we did the reducing here, number 6, 7, and 8, where we cross reduce or reduce on the top and the bottom, that's what we're going to do. We're going to cancel things by reducing. And then once we're done, you're going to multiply straight, just like we did. So again, those 3 steps, basically, I'm hoping if you get confused on where to start, I'm hoping you can go through just a normal fraction and do it the same way. So number 9 is a very basic one where we don't have to factor anything. So step 1 is factor everything. We are at number 9. Just like I usually do, I try to start with one where we don't have to do all the steps. If you can't factor anything, the second step is reducing. You can't reduce anything. When you reduce, the same thing on top and the bottom, you can cancel. We don't have the same thing on top and bottom, not much multiplying. Multiply straight across. I'm going to be honest with you guys, when we multiply, you don't actually have to multiply. So x times x minus 2 is good enough. You can leave it like that. 4 times x plus 3. If you do want multiply it out, you can. I guess for me it's hard because when I actually make you multiply out, there's problems you factor. And then the very next step, you multiply them together. So it seems like you just like take one step forward and one step back. It'll be a little bit different when we do adding and subtracting, but for multiplying, you can just leave it like that in factored form, or multiplying out, that's fine. Okay. Number 10, again, first step is to factor everything you can. So x plus 7 squared, I'm going to make x plus 7 times x plus 7. That denominator, I can factor out a 5. So I have 5. That means I have 2y minus 1. The next numerator, I can factor out a 5. That leaves y minus 3. And x squared minus 49 is difference in squares. So I have x plus 7, x minus 7. And honestly, like I've said, I think I've mentioned this actually earlier this year even. That's the hard part on this one. It's not, I think it's not a bunch of factoring. There's 4 factoring problems all in one problem. People that make every single one factoring problem that has a leading coefficient. And so it just takes like 10 minutes just to be able to get to where you can actually do any math from this chapter. So that was the second step is cancel anything. And now again, I think it gets confusing whether you can cancel the top, if they're in the same fraction or if you cross reduce. So the way I've just started telling students a couple years ago, just if there's the same thing in the numerator or the top and the bottom, then it cancels. So for instance, this x plus 7 can cancel this x plus 7. This 5 and 5, you reduce that fraction like normal. But 5 over 5 is just 1, so that also cancels. Nothing else is on the top and the bottom. So since everything that's done is canceled, what we have left in the numerator is x plus 7. Apparently I put x's and y's in this one. I guess it doesn't matter. Must have copied this from a textbook back in the day. X plus 7 times y minus 3. And in the denominator, 2y minus 1. And x minus 7. Now, I will not do that to you guys. I'm going to do it on that type of problem. When we get to number 12, I will put more than one variable. You'll see the difference. I don't know why that ended up that way, but again, if you put them all as x's, it doesn't make any difference either for this one. Okay. Next one, again, you're going to factor everything you can. So factors of negative 2, that has to be negative 1. That's got to be x minus 2 and x plus 1. Not a bad idea. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So everything's good with that. Factors of 6 and negative 5 are going to be x minus 2 minus 3. You need to double check. Then squared, so x plus 4 and x plus 4. And we have x plus 4 times, or sorry, x plus 1 times x plus 4. That's factored out for you. And again, I apologize if I'm going too quickly over that part, but again, that part should be one that you guys are very familiar with by now. You've done it a bunch of times. That's the time-consuming part. You see things and the denominator, you can cancel. So this is a good example. X minus 2 and x minus 2. One's on the top, one's on the bottom. You can cancel. So x plus 1 is on the top over here, and if on the bottom of your fraction, that's cancel. If it's in the top and in the bottom, it can cancel. X plus 4, cancel. One's on top, one's on bottom. And when I say top and bottom, obviously, hopefully, for the vocab is numerator and denominator. The reason I'm only saying top and bottom is because since there's 2 different fractions, I don't want you to get confused with which numerator and which denominator. So we're just going to say the whole thing top, the whole thing bottom. Everything cancels in the numerator except for an x plus 4. Sorry, everything cancels in the denominator. X minus 3. On your homework, I think I asked you to find the excluded values for these as well. It's the same thing where you just go to the denominator before you cancel stuff. So this one would have 4 excluded values. I'm not going to ask you to do that on a test on this type of problem. If I ask you to do that on the test, it's only going to be the ones we did earlier where you're just simplifying. That's kind of where I decided to draw the line. And this last multiplying. If you understand multiplying, just so you know, don't think that dividing is just going to be a huge error if you're like, this is a struggle for you. Dividing is literally the exact same as multiplying. I'll show you what I mean in a second. So this problem is one that I wasn't going to originally put on there, but it's the basic reason I did is because it is completely different. There are a ton of different ways to do this problem. And again, I've literally tried about every way I can figure out. So if you have a different way of doing this one, by all means, go ahead and run with that. That's fine. I think personally, the easiest way to do this one is before you cancel anything. Because if you look at this, there's a bunch of stuff already. It's like, oh yeah, that cancels. Like, I get that. In my opinion, the easiest way before you cancel anything, just multiply everything straight across. Just get it into one fraction. Now, hopefully you guys noticed the difference between this one. The other ones all had like binomials or ones you had to factor. These are all monomials. They're just one term in each thing. And again, this is the type of problem I will put more than one variable in. So if you just multiply straight across, 6 times 15 is 90, I think. Squared times 8 multiply, you add your exponents, so that's a to the 6th. B times b is b squared. Again, you could multiply your you could add your exponents, or b is b squared. In the denominator, same thing. 5 times 4 is 20. It doesn't matter what order you put it in, but I try to stick to the same order. So a comes next. There is no a in the first equation, the first fraction. A, then b to the 4th times b is b to the 5th. That is the bet, in my opinion, that's the best thing to do first. Once you have it all condensed in one fraction, now you can go through and now you can cancel. I think it's way less confusing when everything's in one spot. So first off, 90 divided by 20, you can actually do that fraction, divide both by 10, so that's 9 over 2. And this is where I don't know a better way to make this nice and clean. Now, when it comes to your fractions of the exponents, technically the thing is what you do is you subtract them. The way I do it is I subtract them, but there shouldn't be a negative exponent. So whatever your answer ends up being, you leave it as positive and you put it wherever the bigger number is. So for instance, a to the 6 over a to the 1st. 6 minus 1 is 5. And I put it up where the bigger exponent was. So this one cancels. We end up with a to the 5th. However, the next one, 2 minus 5 is 3 or negative 3. But I just make it positive 3 in whichever the bigger one was. So the bigger exponent was in the denominator, so my b to the 3rd goes in the denominator. And there's other ways that I've described that. Still kind of on the fence on that's what it is. So once you're done with that, now everything that cancels has canceled. You just put everything you have left. So I have a 9, a to the 5th in the numerator, and the denominator I have a 2, b to the 3rd. Another way I thought about teaching this, and I think I have before, when you subtract your exponents, you just put them all in the numerator, and if they're positive, they're negative, they're negative. And then the second step, do one more step where you put all the negatives into the denominator. I still don't know what the better way of doing it is. So I apologize, we don't have a ton of time, but I am going to have you try number 13 and 14 on your own. Because again, once we get to dividing fractions or dividing these, even if we only have time to do one of them, I think you'll understand that they are exactly the same thing we just did with multiplying. All right, my answers are up there. We only have about 12 minutes left. Make sure we move a little bit, so I apologize if I went too quickly. To make that part easier, it is completely. I just know that if you, I should say this, by all means do it. If you're struggling with this stuff, I like to do it that way just because, let's just say it gets really busy doing it the other way. So where you cross reduce, because what I found is you cross reduce, and then you reduce something else, so you cross reduce that, cross reduce. Anyway, it just gets busy. But again, like I said, I'm super open-minded. If you have, just make sure you show your work. That's kind of the biggest thing with that. Okay. Any questions on that before we move on? Said the rest of this lesson, I'm not going to say it's easy. It's not. The rest of the lesson is not any harder than that. That's the hardest part of today. So, and if you guys remember, maybe you guys are getting the hint with this one. Same thing with division. Now, just like we did before, division is the exact same thing you learned back in elementary school when you divided fractions. If you don't, it's fine. When you divide fractions, you multiply by reciprocal. So 2 over 3 divided by 3 over 4 is the same thing as 2 over 3 multiplied by 4 over 3. Now, the biggest thing with this to realize, two things. You do the reciprocal of the second fraction. Students that mess up because they take the reciprocal of the first fraction. That's not it. It's always multiply by reciprocal. Means multiply, the second one is the fraction, or the reciprocal. Second thing to realize, you cannot reduce multiply reciprocal down. So that's the reason I set this one up. Students say, oh, 2 and 4 can cancel down to 2, and 3 can cancel. No, you can't do any of that canceling until you got it to be a multiplication problem. Once you have it to a multiplication problem, then if you cancel, you can go ahead and do that. This one, I don't have any that can cancel, so it's going to be 8 over 9. That's your answer. But you've got to do that. It's the reciprocal has to be your second fraction, and you cannot reduce anything until you get that to a multiplication problem. Same thing with the next one, 6 over 4, multiplied by 5 over 3. Now the multiplication, you have to go through and say 3 and 6, you could cross reduce that. So 6 divided by 3 is 2, 3 divided by 3 is 1. And that multiplies, is reduced. You can also reduce 4, that's 1 and 2. Or multiply it and then I just realize that fraction, I can reduce that fraction. So whatever, 5 over 2. It is kind of hard because that's not what our problems will look like in this chapter. I just wanted that review. Okay. So keeping that in mind, hopefully you can kind of realize what we're going to do with this. It's going to be a lot of writing, but it's not going to be any harder than before. The first multiply by reciprocal. Do not factor, do not cancel, do not touch any of that. Multiply by reciprocal first. Now, could you factor first? Absolutely. But I very much firmly believe if students start doing factoring or start doing shortcuts or start doing something before they multiply by reciprocal, they end up missing little things and having small mistakes. So same thing, write it in as x squared minus x minus 12 over x plus 3. The first one stays the same. The second one then you write as the reciprocal. You just flip the fraction. Said, we're not doing anything that's more difficult today after multiplication. Is because now it is a multiplication problem. What do to make it by reciprocal? We didn't have to do any factoring. We didn't have to do any work. We didn't have to do calculator stuff. We didn't have to do anything. We didn't have to balance equations. We just this lesson into multiplying and dividing, and then it dawned on me where they're the same thing, and so that's why I decided it was probably worth squeezing in. Because again, once you get to here, now it's the same thing we just did. Factor everything. The first one's going to be factors of negative 12 and add it to be negative 1. So what's that? X minus 4, x plus 3. Numbers, I will figure that out with you. The denominator reduced. And factors of 8 to add up to be negative 6. X minus 2 and x minus 4, I believe. So x minus 4 cancel. Cancels. Nothing else cancels, so all left in the numerator is x plus 5. Keep in mind, remember, if everything cancels, you need a 1 in there. X minus 2. Do not worry about excluded values for these problems. It gets quickly with excluded values in this problem. Okay? But we multiply by reciprocal. So then the can't be. So we're not going to do any excluded values with division. Like I said, or multiplying probably on the test, but definitely division. Like I said, I say that's it, like it's super saying that. I'm saying that's it, as in that's literally the only difference between multiplying and dividing. It's just that very first step. So again, for this one, first get into multiplication problem. So x squared plus 12x. X squared minus 36. Again, if you want to factor, that's on you. I think it's just simpler mentally to go ahead and flip it first. So the first one, you take out a 2x plus the denominator difference of squares, x plus 6, x minus 6. Factors of negative 12 that add up to be 4 are negative 6 and positive 2. And we have 4x squared in the denominator. So again, this is where we can start canceling things. So we have x plus 6, x minus 6, and x minus 6. Now here's one, and I don't know if we've done any of these today like this. One of the things I don't like about this problem is there's just tiny differences where each, well, this is a little bit, it's not every single time. But this one, we have an x and an x squared, so just like we did earlier, we have one x on top and two x's on bottom. That's how I should do it. X on top and 2 on bottom. So I take one x away from both of them, so I still have 1 left on bottom. That's definitely how I should do it. 2 over 4 is like a normal fraction. 2 divided by 2 is 1, so it cancels. 4 divided by 2 is 2. Everything canceled in here except for the x plus 2. The denominator, everything canceled besides the 2x. I apologize to do this, but I'm going to go up and explain one thing. It's not how to explain it differently necessarily, just I think it makes more sense and think about this. A problem like number 14. Cross. This is how I always explain to do this, or this is how I have explained this, I think, since I didn't. That's why I forgot. The way I talk about this is to figure out how to reduce your x's. As many x's as I can. You have to take out the same number of x's in the numerator and the denominator. So the most x's I can take out is 4. I can't take out 5 because the numerator only has 4. I can't take 5 out, there's only 4 x's there. So I'll take out 4. But again, if you take out 4, you've got to take out the numerator and the denominator. So if I take out 4, that means I have none of them left in the numerator. In the denominator, I have 2 left. Now, if you're looking to take out as many as you can, all I can do is take out 1 because the numerator only has 1. So if I take out 1, numerator doesn't have any left. The denominator, I take out 1, I still have 2 left. So that's where you got the x squared y squared. That's funny because I was trying to figure out how to teach that, how you it kind of clicked at the end. But I think that's, again, there's several different ways to explain it. If you want to think about it differently, that's fine. I think that's kind of the easiest way to remember where to put them in the numerator, when to put them in the denominator. And if you do it that way, they're always going to be positive, so you're in good shape. We only have about 3 minutes left, so I'm going to skip the last you do question. But again, it's the same as multiplying. Make sure you're doing your exit ticket. It's not a win exit ticket. I'm going to try to get your test corrections graded and in the grade book, and then I'm going to do the same thing as I did last quarter, where rather than going off of exit tickets, I'm going to go off whoever needs the help to pass. I'm going to look at your final grade, and if you're failing, you're at risk of being signed out to my class. If you have any questions, let me know. For what it's worth, next thing we're going to do is adding and subtracting, and the thing that makes that way harder is because you have to have common denominators, just like you normally do when you add and subtract fractions. So it does get a little bit more confusing.